Hi friends, I am Nirbhadriyademaya from Gopadahalli. PUC 12th class physics inside a planetary model of an electron, protons and neutrons components in the Bohr's atomic model. Both diagrams show electrons orbiting the nucleus of an atom somewhat like a planet's orbit around the sun. It is an analogy that how the planets which are revolving around the sun, the same way electrons which are revolving around the nucleus of an atom. Based on the fundamental concepts of the atomic structure, let us discuss about the Bohr's model of an atom today. Each shell can only hold certain number of electrons in the Bohr's atom. Niels Bohr, a Danish physicist, used the planetary model of the atom to explain the atomic spectrum and size of the hydrogen atom. His many contributions to the development of atomic physics and quantum mechanics, his personal influence on many students to colleagues, and his personal integrity, especially in the face of Nazi oppression, earned him a prominent place in the history of science. Bohr diagram shows certain important things, that is, electrons orbiting the nucleus of an atom somewhat like a planet's orbit around the sun. In the Bohr's model, electrons are pictured as traveling in circles at different shells depending on which element you have. Each shell can only hold certain number of electrons, a definite number of electrons on the principal arbiter K, L, M, N, O, P, etc. Electrons in an atom or a molecule absorb energy and get excited. They jump from one lower energy level to the higher energy level, and they emit radiation when they come back to their original states. This phenomenon accounts for the emission spectrum through hydrogen too, better known as the hydrogen emission spectrum. This is the hydrogen emission spectrum starting from the gas discharge tube containing hydrogen. This hydrogen is passed through the slits, the light, and the slits which filters off, which is passing through the prism, and you will get the spectrum on the plate, photographic plate you can say. This discharge tube emits radiations, slit 1 and grating. Grating filters further, and the photographic film on other detector, you will find the spectrum, the Vibgayar, the spectrum of light or the hydrogen you can say. This is the spectrum of hydrogen what we are going to get during the discharge tube. This is the great scientist Niels Bohr. In the late 1800s, in the 18th century, it was known that when a gas is excited using an electric discharge and the light emitted is viewed through a diffraction grating, the spectrum observed consists not of a continuous band of light, but of individual lines with well-defined wavelengths. The experiments have shown that wavelengths of the lines were the characteristics of the chemical element emitting the light. They were an atomic fingerprint which resulted from the internal structure of the atom. What is hydrogen spectrum? First of all, before knowing to this hydrogen spectrum, you should know what is meant by a spectrum. Spectrum is a phenomena occurs when the light ray passes through the prism. You will get the spectrum of light Vibgayar, that is violet, indigo, blue, green, orange, red colors have been formed on the photographic plate. So the hydrogen spectrum is an important piece of evidence to show the quantized electronic structure of an atom. The hydrogen atoms of the molecule dissociate as soon as an electric discharge is passed through a gaseous hydrogen molecule. It results in the emission of electromagnetic radiation initiated by the energetically excited hydrogen atoms. In the excited state of atom, the photons emitted, and hence the spectrum will form on the photographic plate. My dear friends, the hydrogen emission spectrum comprises radiation of discrete frequencies. These series of radiations are named after the scientists who discovered them. That is Lyman series, Bohrs series, Paschen series, Fermi series, etc. When n is equal to 1, you will get Lyman series. When n is equal to 2, you will get Bohrs series. When n is equal to 3, you will get Paschen series. When n is equal to 4, you will get Fermi series. These are the way of getting the spectrum of hydrogen. Energy level diagram for hydrogen showing the Lyman, Bohrs and Paschen series transitions. The orbital energies are calculated using the above equation, first derived by the scientist by name Niels Bohr. This is the diagram where the photon is emitted, where delta I is the internal energy, where is equal to h nu, where nu is the frequency of radiation and h is the Planck's constant. Lyman series V is equal to RC 1 by 1 square minus 1 by n square, where n is equal to 2, 3, 4, and Bohrs series similarly it follows the equation. Hydrogen spectrum wavelength. When hydrogen atom absorbs a photon, it causes the electron to experience the transition of high energy level to lower energy level. For example, n is equal to 1 and n is equal to 2 when photon is emitted to the hydrogen atom. The electron undergoes a transition from higher energy to lower energy level. So V is equal to 109677 multiplied by 1 by 2 square minus 1 by n square, which is the important thing developed during the spectrum formation of the Bohrs series. The transition from first shell to any other shell, Lyman series, transition from second shell to any other shell, Bohrs series, and transition from third shell to any other shell, Paschen series, etc. It continues. Johannes Rydberg, a Swedish spectroscopist, derived a general formula for the calculation of wave number of hydrogen spectral line emission due to the transition of electron from one orbit to another. The general formula for the hydrogen emission spectrum is given by hydrogen emission spectrum equation, where n is equal to 1, nu is equal to 109677 multiplied by 1 by 2 square minus 1 by n square. This is the equation where r is the Rydberg constant. This is the spectrum of Lyman, Bohrs, Paschen and Fermi series respectively, my dear friends. Thank you. Thank you for listening. If you want to follow our videos from VVSM Academy, don't forget to press bell icon and subscribe. Like, share and subscribe. Thank you.